In this video, we're going to walk through a few SQL injection options. We're going to talk about what SQL injection is and kind of how it works from a hacker's point of view, as well as then talk about some of the ways that we can begin to improve that moving forward. So if we look at what our environment is, we are going to be down here on this Windows 7 machine here, and we are going to try to attack this 2003 SQL server. The 2003 SQL server is not only running SQL, but it's also running Microsoft Internet Information Services, or a web server. And that is being published through the firewall to the rest of the world. So us, as far as the Windows machines, we can just simply attack that port or that IP address, which is then forwarded up to our server, which we are attacking. So let's take a look at it. Here I am, I'm on that external Windows machine, and if I open up, I'm going to open up Firefox here, and I tried to go to that web page, 216.111. I will see I'm prompted for a username and password, and I can go ahead and now type in whichever username I might possibly want and a password. Now these are not valid user credentials, so I would expect when I click submit, I will get a error message saying failed login, unknown username or password, access is denied. Now that's exactly the way it should be happening. What's happening as far as how this works in the background is the web server is passing the credentials I type in into a database and is doing a lookup to see if that database contains the username and password I listed. Let's take a look to see exactly what that means. So I'm going to jump onto the SQL server. Here I am, I'm on the SQL server, and I'm going to open up a tool called Profiler. So on the start menu here, all programs, under Microsoft SQL Server, Profiler. I'm going to create a new profile or a new trace. For the SQL server, I'm just going to type in dot, which means the local machine, with Windows authentication, and OK. Asks me what type of trace I want, and there are different types of options I may want to include in here. I'm going to stay with the defaults and click run. Now what a profiler does is it listens for all transactions that are happening against the SQL database. When it sees a transaction, it will write out the contents of that transaction on this screen so that we can then later observe it and see what's going on. So let's show that as an example one more time. I'm going to come back to my other machine. I'm going to click back arrow, and I'll type in a username and password, and I'll click submit. Again, I still get unknown username or password, which is fine. What I want to do is I want to see the actual command that's being run. So if I come back to the profiler, well, I see right here I've got some data in my list here, and I can see there's an actual SQL command that's being run. See if I can make this a little bit bigger. There we go. So what's happening is this website is passing a SQL query to the machine that is saying, hey, go ahead and select star from user. So select from the users table. So in the database, there's a table called users. And specifically it's saying where username is this and where the password is that. Now with SQL, there are ways that you can actually chain SQL commands together in order to have multiple things run at the same time. An example of that would be if instead of this username, I typed in something different. For instance, if I had a username of Jesse, and in my username field, I typed Jesse single quote or 1 = 1 dash. So if let's go ahead and just replace this. I said copy. If I replace the username with this down here, then suddenly I have this command, which looks kind of broken, and it is, but what's happening is we're selecting star from users where username equals Jesse or where 1 equals 1. This dash dash means that's the end of the line, which means stop evaluating this command. So when this query comes in into the machine, into the SQL database, it's going to come through and it's going to say, I may or may not have somebody named Jesse, but 1 always equals 1. So I'm going to select somebody from users, and therefore I'm going to return some sort of a result. That's kind of how a SQL query or SQL injection happens, is we start throwing in some unexpected data into these fields that is specifically crafted for people who know what they're doing, can get past our security. So let's actually try this. Let's try this as our username. I'll leave the trace going on here as far as on our SQL profiler, and we'll go back to our Windows 7 machine. And start off, we'll just replace the username here with exactly that. Jesse, single quote, since SQL understands single quotes, or 1 equals 1 dash dash. Now, when I click submit, I'm going to get a different error message than before. This is not saying I'm failing at a username or password. This is just saying that my password needs to be bigger. Now, that happened really quickly. The fact that it happened without actually submitting any content on the page tells me that this didn't actually go back to the web server. This is something happening on my side, on my client side, that's prompting for a password to be a certain number of characters. And we can look at this. Let's see. Username contains illegal characters. We can look at the content here. If I right click and view page source, we can look at the content of this file, and we'll see a section here that's called JavaScript. Great. Make it bigger. And the JavaScript here has a couple of sections. The first one is checking to see if the username length is greater than 20. If it is, then it sends out an alert saying your username must be less than 20 characters. Try again. There's also another one that says look for the password length, and it says your password must be greater than 7 characters, which we just saw. Oops. And then lastly is we've got some illegal characters where it says your username contains illegal characters, or your password contains illegal characters. These are some ways to be a little bit more intelligent about the data that our website is accepting. But it's also JavaScript, which requires the client to play along with it and run it properly. We don't actually have to run this JavaScript. Just because it's there, we don't have to actually pay attention to it. We could turn this off in our web browser. And that's exactly how we're going to defeat it. Close this down and come back to our web browser. For this specific version of Mozilla, you go to Tools, Options, Content, and I have a Enable JavaScript tab or checkbox. I'm going to uncheck that and say OK. Since I turned off JavaScript, those checks that we just saw in the code don't apply to us anymore. And now when I run this command, it should run it, hopefully, directly against the database. So if I click submit, I now see that my message has changed. It no longer says unsuccessful login, username or password are bad. It now says, yeah, successful login, specifically for user A. Anderson. That's kind of interesting. Let's look back at the table or at our SQL profiler to confirm exactly what happened. So we can see here is our command. I make this bigger. Don't think I can. But here's our command. Let's go ahead and copy that, put it in a notepad so it's a little bit bigger to see. That right there is what I typed in. The actual SQL command that came out was select star from users, where username equals Jesse1, Jesse or 1 equals 1, and password equals blank. The double dash here meant stop processing. That's the end of the line. Anything that comes after this is a completely separate line. Therefore, the and isn't included. It's either a username equals Jesse or 1 equals 1. There may or may not be a user named Jesse in here. We're not entirely sure yet. But 1 always equals 1. Therefore, the very first user that comes back in our select statement is the user we're going to log in as. And it's just that simple to circumvent some SQL injection attempts. And just as we saw, we did actually log in as a Anderson. Yeah. So let's take that a little bit further and let's see what else we can do in here. Let's see if we can get access to this users table. So I'm going to go back to my other Windows machine here. I'm going to click back and I'm actually going to clear that out. And I have a file here called SQL, which has lots of different SQL commands, SQL injection commands spelled out for me. So we can see our first one there, Jesse or 1 equals 1. So that's the very first command that we just ran, and we saw that it allowed us to log in. Next, we want to do this command. So what we're going to do is we're starting off with a single quote, which means close the user field, and then a semicolon, which means start another command. And in that new command, we're going to execute something. What exactly are we executing? Well, we're executing the sp_make web task. The stored procedure called make web task. SP stored procedure, which does something on the computer. What exactly it does, we don't know yet. But if we look through here, we can see that there is a reference to a file called users.html. And specifically it says select star from users. So it looks to me, if I'm reading this properly, it's going to perform that select command. And it's then going to save the data into a users.html file. Now, if I look right now, there shouldn't be a users.html file. Right, page is not found. But once I run that command, or once I run that sp make web command, it should select star from users and then save the output into this location on the C drive, which just happens to be the location that the website is being published to. So let's try that. Just going to copy and paste that right into the username field here. Still have JavaScript turned off, so it will allow us to submit it. Failed. But that's fine. We didn't actually send a username and password. We didn't tell it that we wanted it to log in. We told it we wanted it to do something else. And what exactly was that? Well, we wanted it to populate that users.html file. So now when I refresh it, there I can see. So I can see here we have a username, A. Anderson. That was the name we logged in with just a couple of minutes ago by accident. With a password, Subway Eat Fresh. Interesting. There's also a B. Beetle with Burger King, R. Carey, Disney World, and you can see the usernames and passwords here. I'm curious. Let's try logging in as A. Anderson with Subway Eat Fresh. So I'm going to click back, clear, paste, paste for the password, and then submit. And it says, yes, you logged in as A. Anderson. So we did actually get the username and password out of the database, and then we're able to log in with that account. Now, why did I choose A. Anderson? Just, it was the first one on the list. I should have been able to choose any other username and password in here, and they should have worked perfectly. Okay, well, let's actually confirm that. Let's go back to the SQL Server. I want to actually confirm myself that command has run properly, and that is the information that's actually there. First off, let's go back to the trace here, or the SQL profiler. See, we did a create procedure. Where was our exec? Select star from users. Nope. Yeah, so it did a, oh, pause that. So it created a procedure which was select star from users. It looks like it then ran that procedure, which was this right here, and then SQL populated that into an HTML file for me. So the command actually was run. Once that was done, we finally, yeah, there we go. Once that was done, we then finally logged in as A. Anderson, which was that very last pop-up right there, A. Anderson with Subway Eat Fresh. But now let's check out that users table just to be sure. Yes, close it. Go back into SQL Enterprise Manager. And we'll see our databases. I'm assuming since master, model, MSDB, and tempdb are all common, I'm assuming Northwind is our database. Now look under tables. I should find a users. No. Let's see, what other tables are there? Let's see. Oh, is that under master? Got to find the right place here. Master, tables, scroll on down, users. And then open and return all rows. And in here, we can see there's our A. Anderson with their password. Oh, all right. So it was actually the contents. We could have done quite a few other commands. For instance, we can see in our SQL.txt file here, we have a couple of different commands. The next one is an insert into users. So we can actually create additional users into our database. We can run a whoami command in order to find out which user the SQL database is running as. Once we know who the SQL database is running as, we can make some assumptions as far as to their permissions. And then the rest of these commands actually walk through installing some sort of malicious software onto the computer that can then remotely manage it or remotely control it. And that's just a few of the examples. We could have easily done a drop table as far as one of the commands that we sent in there, which would have just simply dropped the database tables and deleted them out of the system. But let's talk about some of the things that we could do as far as to fix this. And it all kind of comes around that query, or the way that the query is performed on the database. If I go and I look at the database files, or at the website files, let me see inetpub www.root, and it's probably going to be admin login.asp. Let's open that up in Notepad. Make it bigger so we can read it. Now, this is ASP, not ASP.NET, so very much of a different programming language than any you might have seen previously. But this function right here called login is where most of it's happening, and there's not a whole lot going on, so hopefully we should be able to figure it out. Start off by defining what a username and password are, and we're saying, yeah, go ahead and look in what's called the query string, or the path that's up at the top in the address bar. Find the username and assign that to username. Find the password and assign that to the password. When that's done, create a SQL string, which is going to be an extremely simple way of doing it here. We are constructing the string bit by bit. So we're starting off with select star from users where username equals single quote, the username that we just got from up above, another single quote, and password equals single quote, and the password we got from up above, and another single quote. So that's how we're building the SQL query together. It then executes that against the database. Probably the best way to overcome this is not to use an actual SQL query. We just saw a command where we did what was called a stored procedure. We're not exactly sure what was included in the stored procedure. We sent some input and it returned back the results, and that would be the way to log in users. We should not be selecting users. We should simply be sending, hey database. So actually the var SQL should be something along the lines of exec sp underscore login. Let's see, something like username. Trying to remember the exact format here, but it'd be something along the lines of plus username, comma, plus password. I'm missing some extra quotes in there, but that's basically the idea, to where instead of the website sending the full SQL query, we're simply sending down to the database saying, hey, perform this stored procedure. Perform some hidden logic and only pass it the username and password. And then inside the database, inside the stored procedure, we can be picky about exactly what content is being included with this stored procedure. So that's step number one, is to use stored procedures instead of a SQL query. And most websites nowadays should be using this, although this is still probably one of the #1 items that can pop up with regards to website issues is injection of some kind, whether it's SQL injection, code injection, or something else. So that's issue #1 with this website, is using a SQL query instead of a stored procedure. Second issue with this website is, well, the passwords are written and saved in plain text. There's no reason for passwords to be stored in plain text. And in fact, it's horribly insecure for reasons we just saw. The fact that once I get into the database here, me as an admin, I can see all this content. And if an admin can see this content, then that means a skilled hacker or a lucky hacker can see all of the content as well. Therefore, all of these user accounts are now should be considered hacked, and all of them should be required to change their passwords before they can log back in again. There are different ways to be able to do this. First is to hash the passwords and store the password hashes instead of the passwords themselves. Along with hashing them, you can salt the passwords, makes them a little bit more secure, and there's plenty of ways to be able to do that. Kind of outside the scope of this class, but yeah, there's plenty of ways to do it. Basically saying, if you ever get to a situation where you're working with an organization or a website and you say, hey, I've forgotten my password, and they send you back a clear text version of that password, this is what they're doing, and it is an insecure format for saving their database, or for securing your passwords. All right, so there you go. That is an introduction to SQL injection.